Senang. So tadi itu chapter 5, sekarang chapter 6. Okay. Okay, so introduction. Okay, for chapter 6. Okay, in chapter 6 we will learn about energy and also energy transfer. Okay, tadi dalam chapter 5 kita dah belajar sikit. Okay, so introduction. Okay, kejap. Point. Okay. Okay, so if we take entire room, so katakan you ada satu bilik, so dalam tu you letak satu kipas ataupun a fridge, okay, and the fridge is connected to electrical supply, so fan pun connect to electrical supply, so you have a room which is well insulated, okay, well insulated. Okay, before that, so there is a term called diabetic. Diabetic maksudnya there is no heat transfer. So maksudnya no heat transfer. Okay. So kalau you letak satu bilik yang isolated, kemudian you buka peti sejuk, then you connect it to electrical plug point and it's on lah. So after 1 hour, what will happen to the room? So bilik itu akan jadi lagi panas ke dia akan jadi lagi sejuk? Okay, soalan ni pernah keluar dalam final. Okay, so you buka, so well insulated room. So you ada peti sejuk, you buka peti sejuk, then you connect it to the electrical wire. Okay, so meaning the fan ataupun the fridge dia on lah. So maksudnya dia berfungsi. Then you tutup the bilik. Then after 1 hour, what will happen to the room? Bilik tu akan jadi sejuk ke bilik tu akan jadi panas? Siapa cakap sejuk? Okay, so ada few cakap sejuk. Siapa cakap akan jadi panas? Seorang je, suam. So ada yang cakap suam. Okay, so maybe lah suam. Maybe if 1 hour dia jadi suam lah. So let's say one day. So katakan sehari. So dia akan jadi panas ke sejuk? Okay, dia akan jadi panas actually. Okay, so kalau you baca dekat sini lah, you akan tahu jawapan. Okay, the only energy interaction involved is the electrical energy crossing the system boundary. Sebab dari luar, apa yang masuk adalah electrical energy, and dalam di belakang refrigerator ataupun fan ni dia ada motor ataupun some system. So you tengok belakang, kalau you balik rumah, you maybe boleh check tengok lah belakang fridge, walaupun dalam tu dia sejuk, belakang tu still dia panas. Sebab dia ada heating element ataupun cooling element, so dia perlukan some kind of energy transfer dalam tu. So belakang tu dia akan jadi panas. Kipas pun you tengok, depan maybe you dapat angin yang sejuk, tapi you sentuh motor tu dia akan jadi panas. Sebab tu we don't really encourage you to on the PC too long. Siapa yang tak pernah off PC dekat bilik? Kalau PC tak apalah, kalau laptop memang dia jadi payah. So you need to off until it cool down, then after some time baru dia jadi you on balik. Okay, so don't run something continuously. Okay, so you need to off. Even modem dekat rumah pun sama. Modem pun kita tak pernah off kan. So if you not really using ataupun you keluar, off. So balik tu you baru on balik. So it will the device will be last long lah. Okay, kalau you nak dia last long, so you do like that. Okay, so that is something that we want to understand. Okay, as a result of the conversion of the electric energy consumed by the device to heat, the room temperature will rise. Okay, so temperature will rise sebab electrical energy. Okay, energy dari luar, electrical dia keep on masuk, so the fridge will become panas after some time. Okay, and also the fan pun akan jadi panas. so it will increase the temperature of the room. Okay, so this thing you need to understand. Sebab itu kompresor aircon kita tak letak dalam bilik. Siapa letak aircon dengan kompresor aircon dalam bilik? So bilik ni pun ada aircon, tapi kompresor ada kat luar. So sebab you want the heat to go out. Okay, so the cool air to come in. Okay, so that's the thing. Tapi dekat overseas, tempat yang sejuk, katakan macam Switzerland, kompresor dia letak kat dalam, aircon dia letak kat luar. Memang sebab you nak bilik tu jadi panas. Tapi dia tak pasang macam aircon lah, dia ada heating element. So dia selalunya letak dekat lantai. So kalau you biasa pergi Korea ke, memang ada lah. Japan semua memang ada. So you on, dia memang akan lantai you akan jadi panas. Okay, so there's some form of how you can regulate the temperature. Okay, so as an engineer, you need to know how to manage your energy. Okay, so that's the understanding lah. Okay, the form of energy. Energy can exist in numerous forms. Okay, so energy can be in thermal, mechanical, kinetic. So apa contoh mechanical energy? Siapa boleh bagi tahu? Mechanical energy. So apa contoh? Thermal kita tahulah. So kita panaskan, kita dapat energy, ataupun dari matahari, ataupun dari lilin ke. So you can get the thermal energy. So what about mechanical energy? Dari mana kita boleh dapat mechanical energy? Siapa boleh bagi tahu? Satu contoh mechanical energy. Kalau sekarang tak boleh jawab, exam pun you akan fikir juga, kan? So mechanical energy. So from where you can get mechanical energy? Okay, satu contoh adalah spring. So you mampatkan, so dia ada potential energy, so you release. So spring is totally a mechanical energy. Okay. Dan kinetic energy. So kinetic energy dapat dari mana? Water turbine ataupun kenderaan yang bergerak. So anything, whatever that is moving, so you can create a kinetical energy. Potential energy, okay, empangan, static. Okay, so magnetic, so from magnet lah. So chemical, from a chemical mixture. And nuclear. Okay, nuclear energy something yang kita biasa tengok, but nuclear is a very powerful thing lah. So I think kita pun tahu what happened to Japan, Hiroshima and Nagasaki. So I think the whole place gone because of a small nuclear. It's not actually small lah. Okay, a nuclear reaction. Okay, so nuclear reaction, certain country dia gunakan nuclear plant untuk hasilkan elektrik. Macam Malaysia tak adalah, kita gunakan hydro. So hydroelectric kita gunakan arang. Okay, dekat Perlis ada Perlis power plant. So yang tu kita mostly gunakan arang. So kita gunakan arang untuk hasilkan arang, and also other property lah. Kita tak ada hydroelectric, tapi dekat Malaysia kita ada a few hydroelectric plants which can generate the electrical energy. Okay. Tapi certain countries macam I think Pakistan, kita ada macam US, then we have Japan, Korea. So these are some of the countries that use a nuclear plant to hasilkan electrical energy, which can be useful. Tapi must be very careful lah. So the reactor must be always checked. Pastikan tak ada leakage. Kalau tak, dia akan jadi macam Chernobyl. Siapa tahu Chernobyl? So Chernobyl, so nuclear plant meletup. Then until now the place is tak ada orang. Semua mati. Okay, Chernobyl, I think it happened in 1986. Dah lama lah. Okay, siapa ada 1986? So 1986 tak ada So tapi it happened a few years back lah. I think almost 40 years back. But it is a very big nuclear disaster. Okay, after Hiroshima and Nagasaki. You boleh tengok lah dalam YouTube ke. So what happened? Okay, so thermodynamics deals with the change of total energy. Okay, so we know the energy cannot be destroyed or created. It only change form. So the term of total energy is what we use in thermodynamics for our studies. Okay, macam tadi I bagi tahu macroscopic and microscopic. So macroscopic form of energy is something that you can see. Okay, something that you can see macam electricity ataupun surface tension. Okay, so that is something that we can see in our daily life. And microscopic form of energy, the form that is hidden, apa yang kita tak nampak. Okay, it's a molecular activity macam nuclear. Kita tak nampak, but it's actually pecahan nukleus ataupun nukleon dalam tu hasilkan energy. Okay, so there's something that microscopic. Then there's another important term which is internal energy. Okay, internal energy ataupun kita selalu letak alphabet U. Okay, U, the sum of all the microscopic form of energy. So ada 4 jenis microscopic energy, internal energy. Sensible, latent, chemical and nuclear. So ada few slide on that. So you campur all that, you dapat internal energy. So there are some studies that need you to measure what is the internal energy. Okay, total energy. Okay, total energy of a system consists of three things. One is the kinetic energy, KE, okay, and potential energy, PE, and also internal energy, U. Okay, so kalau dalam exam dia suruh you explain total energy of a system. So you gonna explain based on this formula. So total energy is actually combination ataupun addition of internal energy, kinetic energy, and also potential energy. Okay, so internal energy kita boleh dapat U. Then kinetic energy kita dapat dari formula fizik half mv square. Okay, ataupun mv square over 2. So actually half mv square. And potential energy adalah mg z. Z adalah differences in height. Okay. And total energy per unit mass per kilogram. Boleh tengok dekat unit kat belakang. Yang ni kilojoule, yang ni kilojoule per kg. Okay. So kalau you bagi dengan kilogram, itu adalah per unit mass. So semua akan jadi kecil. So E akan jadi kecil, U akan jadi kecil, KE pun akan jadi kecil, PE pun jadi kecil. So from kalau you tulis formula macam ni, saya tahulah you are actually referring to per unit mass. So jangan silap tulis. So kalau silap tulis, so semua unit dekat belakang ni bagi dengan M. So yang ni jadi U, yang ni M buang jadi V square over 2, yang ni jadi GZ. Okay, so this is how you can calculate the total energy. So kinetic energy, the energy that the system possesses as a result of its motion. So apa-apa yang bergerak dia hasilkan kinetic energy. Okay, so yang ni macam tadi lah. So KE adalah mv square over 2. So per unit mass jadi V square over 2. Okay, so boleh tengok example ni. Okay, kereta bergerak at 80 km per hour. Okay, so mass adalah 900 kg So yang ni adalah satu contoh. So ini adalah contoh soalan. Okay, determine the specific kinetic energy. Kalau dalam soalan dia keluar term macam ni, specific kinetic energy. Specific maksudnya apa tu specific? Tadi kita belajar specific. Apa tu specific? Kalau specific maksudnya you kena cari per kg ataupun per unit mass. So you kena gunakan formula ni. So specific kinetic energy of a mass whose velocity is 30 meter per second in kg per kg. So you gunakan formula ni. Kinetic energy per unit mass adalah V square over 2. Okay, V adalah 30 meter per second square over 2. Ini unit conversion. So you dapat dalam kg per kg. Okay, similar for potential energy, PE. So potential energy, the energy that the system possesses as a result of elevation in a gravitational field. Okay, dalam gravitational field, kalau ada ketinggian, kita ada potential energy. Okay, so the formula tadi, PE adalah mgz, and PE per potential energy per unit mass adalah gz bagi dengan m. Okay, so example, okay, determine the specific potential energy in kj per kg of an object 50 meter above a datum in a location where gravity equals to 9.8 meter per second square. Okay, so apply dalam formula tadi. So 9.8 kg, so formula dia adalah gz. So G adalah 9.8, Z adalah 50 meter. Ini adalah unit conversion. So you dapat 0.49 kg per kg. Okay, so most closed system remain stationary during the process, thus experience no change in the kinetic and potential energy. Yang ni basically lah, normally it will be like this. So stationary system, a closed system whose velocity and elevation of the system remain constant. Kalau velocity dengan elevation, ketinggian dengan speed adalah sama, so maksudnya the system adalah stationary system, constant, selalunya sama. The change in the total energy of a stationary system is identical to the change in the internal energy. So total energy dia totally depend on the internal energy tadi. So dia tak berubah. So sistem pun the total energy pun tak berubah. Okay, the control volume open system typically involve fluid flow for a long period of time, and it is convenient to express the energy flow associated with the fluid stream in the rate form. Okay, tadi kita tengok control volume ataupun open system. So open system maksudnya mass is coming in and going up. Okay, so macam water heater tadi, air masuk dan air keluar. Okay, volume tak berubah. So that's what we call it as a control volume. So dalam tu, so the energy flow is totally depend on the fluid. Fluid yang masuk dan keluar. So it can be a gas or it can be a water ataupun anything lah, liquid. Okay, and kita selalunya concerned about the rate. Rate maksudnya over time, berapa banyak yang masuk dan berapa banyak yang keluar. Okay, so energy flow associated with the fluid, normally kita ada mass flow rate and also energy flow rate. So ini adalah formula dia. So kita dah belajar dalam chapter 4. Okay, so mass flow rate M rho times with specific volume, ataupun rho area times with velocity, average of the velocity. Okay, so internal energy, some physical insight to internal energy. So tadi kita tengok ada internal energy, ada 4 jenis internal energy. So soalan ni pun pernah keluar dalam exam. Okay, so some physical insight to internal energy. So the first type of internal energy adalah sensible energy. Sensible energy, so is internal energy associated with the kinetic energy of the molecule. So dalam something you have a molecule. So molecule dia selalunya bergerak. So when it move, it will generate a internal energy called a sensible energy. Okay, so that is the first type of internal energy. The second type of internal energy, latent energy. Internal energy associated with the phase change. Okay, so katakan macam saya ambil example of water. So water selalunya boleh ada dalam berapa fasa? 3 fasa. So it can be either wap air ataupun water or ice. Okay, so ada 3. So either pepejal, cecair ataupun gas. So all are water. Okay, tapi cuma different. So kalau ada phase change, the latent energy also change. Okay, so maksudnya dari pepejal, maybe the latent energy is sikit. Tapi kalau dia jadi cecair ataupun gas, so the latent energy inside is increasing, especially in the gas form, because this latent energy and sensible energy are related. So kalau dia ubah fasa, so pergerakan antara molekul pun bertambah ataupun berkurangan. So it will control the internal energy. Okay, so that is what is saying. Boleh tengok dekat sini lah, sensible and latent energy are related. Okay, latent energy berkaitan dengan perubahan fasa, sensible energy berkaitan dengan pergerakan molekul. So it's berkaitan. Okay, then we have a chemical energy. So chemical energy is actually associated with the atomic bond in the molecule. Okay, atomic, so maksudnya dalam dia. So ada nucleus, ada proton, ada neutron, semua tu kan. So that is what we call chemical, but it's not as small as a nuclear energy. So nuclear energy is related to proton and also neutron, okay, and the atom itself, but chemical is more in a bigger scale. Okay, it's more on the bond, atomic bond, and also chemical bond, which is destroyed during a change in the internal energy. Okay, so boleh tengoklah dekat sini some of the pictures for you to understand. Okay, so boleh tengok dekat kotak ni dekat bawah, thermal internal energy, kalau you campur sensible and also latent energy. So yang itu berkaitan dengan thermal internal energy, and internal energy in general adalah berkaitan dengan all the 4. You campur all 4, you akan dapat internal energy in general. Okay, so boleh tengok dekat sini, ini yang saya bagi tahu tadi. So molecule, so kalau molecule of water, so H2O. Okay, so molecule of water ada satu atom oxygen and 2 atom hydrogen, so it forms a water molecule. Kalau atom, so ada elektron, nucleus. So kalau dalam bentuk nucleus, dia ada neutron dengan proton, and you pecah lagi, so you ada neutron. Kalau yang ni adalah neutron dengan proton, so dalam tu you ada something yang kita panggil as quark. So nama dia pun pelik kan, quark. So which is what we focus on nuclear energy generation. So kita pecahkan dalam ni. So kalau dia pecahkan, dia more energy is released. Okay. Okay, total energy E of a system can be contained or stored in a system, and thus can be viewed as a So kalau total energy tu you boleh simpan dalam satu sistem ataupun satu container ke ataupun satu room, so we call it as a static form of energy. If you can contain it or you can store it in a system, so we call it as a static form of energy. There's another term that called as a dynamic form of energy. So dynamic maksudnya bergerak, so something yang very not stationary. Ataupun kita panggil juga as energy interaction. Soalan ni pun pernah keluar. Energy interaction. What is energy interaction? So energy interaction means a dynamic form of energy. Energy yang bergerak. A form of energy not stored in a system can be viewed as a dynamic form of energy. Okay, so this one you need to understand. The dynamic form of energy are recognized at the system boundary as it crosses it, and they represent the energy gain or loss by the system during the process. So yang ni boleh tengok dekat gambar ni. So you have a turbine, water turbine. So dalam ni you ada water molecule, so energy molecule. Dia dalam ni dia berpusing ke tak? Siapa cakap berpusing dalam ni? So dalam ni berpusing ke tak? Tak berpusing. Sebab molekul tu dia hanya bergerak ke keliling. Dia tak pusingkan turbine ni. So bila yang ni akan pusing, waktu you letak turbine kat luar. So and you have a opening here. So waktu air ni keluar, dia akan pusingkan turbine. So this is the concept that we use in a hydroelectric dam. So we try to create a kinetic energy from the potential energy. So potential energy tukar ke kinetic energy, dia pusingkan turbine. So the turbine will create a electrical energy. So that are the things that create. So boleh baca lah some description ke atas. Okay. So the only two form of dynamic form of energy associated with the closed system are heat transfer and work. So it goes back to heat transfer and also work. Okay, so two types of energy that we will study lah. Okay, the differences between heat transfer and work. Okay, the energy interaction is heat transfer if the driving force is the temperature difference. Okay, two types of energy transfer. Satu adalah work and satu lagi adalah heat transfer. Heat. Okay, so heat transfer, energy interaction is heat transfer kalau the driving force, apa yang perubahan dalam tu adalah temperature. Kalau perubahan tu berkaitan dengan temperature, kita panggil as a heat transfer. Kalau yang tu dia tak berkaitan dengan temperature, automatically dia jadi work. So yang ni you kena understand lah. Okay, the last two ayat. Okay, take 5. I tengok so a lot of thing, but it's okay, we go slow. So kalau I tak boleh habis, kita akan sambung on Friday morning. Saya dah bagi tahu tadi. Okay, so we'll take 5. I akan continue panggil nama lah. Arif Syairan. Arif Syairan ada. Ajwad Fatih. Danny. Fatin Syamimi. Idina Nur Akila. Jiwa. Kamal Faris. Kamal Faris. Ku Musfira. Lutfi Ladi. Maira. Muhammad Aiman. Muhammad Firdaus. Muhammad Aikal. Muhammad Faiz. Muhammad Firdaus Kairozi. Muhammad Firdaus, Muhammad Farid. Muhammad Firdaus, Muhammad Farid. Ada. Muhammad Firdaus Romi. Ilham Amir. Khairul Azhar. Wafi Hakim. Zahirul Hakim. Nirvesh. Nur Aimi Nadira. Nur Aisha Amira. Nur Dinish ada. Nur Fakira. Ha? Nur Afizatu. Nur Uwaiya. Nurul Farain. Nurul Shakira. Pritika. Sharmila. Syahid Azimi. Sufyan Davis. Syarul Anwar. Tilagan. Umar Razi. Unku Arman Shah. Wan Nur Kamarina. Okay, we will continue. Okay, energy transfer by heat. Okay, so earlier I mentioned that energy is transferred by heat or work. Okay, ada dua benda. Okay, either pemindahan arah ataupun pemindahan tenaga melalui kerja. So there are two things. Okay, so what we will see first, energy transfer by heat. Okay, so heat, the form of energy that is transferred between two systems. Okay, so dia ada dua sistem, so surrounding dengan sistem ataupun sistem dengan sistem. Okay, or system with the surrounding by virtue of temperature difference. Okay, dalam heat energy transfer wajib ada temperature difference. So kalau dia ada temperature difference, maksudnya you automatically kena tahu energy itu adalah berkaitan dengan heat. So is related to heat. Okay, so you have a closed system where the mass equals to constant and you have a system boundary. The only two form of energy that can be transferred is the heat energy. Okay, it can come in and or out, and the work, it can come in and out. Okay, so you can see this picture. So you have a soda. which is 25 degrees Celsius. Okay, and your room temperature is 25 degrees Celsius. Okay, then you ada 3 can. Okay, satu adalah 25 degree Celsius, satu lagi adalah 15 degree Celsius, dan satu lagi adalah 5 degree Celsius. Okay, so room temperature adalah 25 degree Celsius. Okay, what will happen to the first can? So no heat transfer. Sebab so it already reached thermal equilibrium. Okay, sebab dia temperature dia pun 25 degree Celsius, room pun 25 degree Celsius, so no heat transfer, no heat energy transfer. Okay, the second can 15 degree Celsius and surrounding is 25 degree Celsius, so heat will enter, heat akan masuk, then after some time 15 degree Celsius akan jadi 17, akan jadi 20, sampai dia jadi 25, then dia akan stop because it's already reached the thermal equilibrium. Okay, and you have 5 degree Celsius, heat is transferred in, sebab dia ada perubahan, then after some time jadi 10, 15, 20 sampai 25 dia stop. Tapi apa perbezaan antara the second can and also the third can? Yeah, time. So katakan you ambil you ambil maybe dalam 5 minit, dua-dua pun the time you make it constant 5 minit. So what is the difference? Temperature different, okay, betul. So apa yang akan berubah? So actually kalau you tengok dekat sini heat is transferred at 8 joule per second, and here 16 joule per second. So maksudnya kadar pemindahan haba tu berlainan. So the rate of heat transfer is different. So itu yang kita bagi tahu dekat sini. The temperature difference is the driving force in the heat transfer. Maksudnya dalam heat transfer, so temperature wajib ada. The larger the temperature difference, the higher is the rate of heat transfer. Okay, so kalau you nak tahu which one has the higher heat transfer rate, you ambil the room air temperature, room temperature, tolak dengan the temperature here. So berapa perbezaan dia? Can kedua, berapa perbezaan temperature berbanding dengan surrounding? 10. So 25 tolak 15. So yang ni 10. Yang ni can ketiga 20. So kalau gradient dia ataupun julat dia besar, the range is bigger, the gradient will be bigger. Maksudnya can ketiga dia akan cepat terima haba, so that dia boleh berubah. Yang ni dia kurang. So kalau yang ni 20 degree Celsius, lagilah kurang. So maybe the heat transfer rate will be 4 joule per second. Sampai yang ni kenapa dia tak dapat first can, kenapa dia tak ada perubahan haba? Sebab the heat transfer rate adalah kosong. Faham tak? So that is the thing that we can understand from this slide. Okay, so the heat is the energy in transition. Yang ni the real life lah. So you are eating a potato, maybe you are baking a potato ataupun you letak potato dalam microwave. So dia akan dapat the heat inside. So heat will be generated, ataupun maybe the baked potato dia dah panas, you letak dekat surrounding. So what will happen? Yang ni dia panas, so surrounding dia sejuk, so heat will be coming out from the baked potato to the surrounding. Okay, so as the heat crosses the boundary, so boleh tengok garis putus-putus dekat sini surrounding the baked potato. So when the heat is transferred passing by the, yang ni dia macam checkpoint lah. Macam dengan Malaysia dengan Thailand kan ada checkpoint. So kalau you pass by, you chop your passport, then you go to the other country. Similar lah. So at the boundary there's a transfer. So kalau the heat is going or coming in, passing the boundary, then we will consider that the energy is transferred. Kalau energy still dalam ni, so it still consider the energy is not transferred. Energy must cross the boundary. Either dia coming in ataupun going out. Okay. So during the process which there is no heat transfer is called the adiabatic process. So adiabatic maksudnya dalam ni. So when the system is well insulated, so the heat is not going out. So maksudnya the heat is inside and the system and surrounding are at the same temperature. Macam tadi lah. So no heat transfer rate. Rate adalah kosong sebab temperature kat luar dengan dalam adalah sama. Meaning there will be no heat transfer and there will be no heat transfer passing by the boundary if the system is well insulated. So macam microwave lah. Dalam tu dia well insulated, kat luar you tak rasa kepanasan dia. Unless you tekan, you sentuh lah. Sentuh maybe you rasa panas. Tapi kat luar tu you tak rasa sangat. Sebab the system is almost well insulated. Okay. Kalau the insulation, kalau you buka, tapi I tak pastilah yang ini possible ke tak. Tapi dalam oven possible. Oven you buka pintu tu, kemudian you on the oven. So after some time your surrounding jadi panas. Sebab it's not fully insulated. Okay, so that is what we need to understand. So during a diabetic process, the system exchanges no heat with his surrounding because it is well insulated. Macam gambar ni lah. So you ada insulation keliling. So no heat transfer. So kalau no heat transfer, Q adalah kosong. So meaning it is a diabetic system. Bukan diabetic bukan diabetes. Ini air diabetic. Okay, so no heat transfer. Okay, a form of energy. So heat as a energy unit. So heat selalunya kita ukur dalam kilojoule. The amount of heat transfer from during a process between two state. So katakan dalam proses tu ada dua state, state 1 and state 2. Kita selalunya tulis Q12. Bukan Q12. Q12, kita selalu mention Q12 ataupun Q12 or just Q. You can just write Q. Per unit mass, kita selalu bagi dengan mass Q over M. So yang ni jadi Q kecil. Okay, then you have changes with time. Kita ada Q dot. Kalau dia tulis Q dot, kita tahu dia adalah berkaitan dengan masa. So it is changing over time. That's 10 second ke 20 second ke. So you have the calculation is berkaitan dengan masa. Then you have ini samalah. So you kali dengan masa, dia akan jadi Q. So the rate is constant. Okay, so boleh tengok dekat sini gambar kotak ni, how you can convert. Okay, so Q adalah 30 kilojoule because you are receiving the heat from the outside. So mass adalah 2 kg and the time adalah 5 second. Okay, macam mana dapat Q dot ni? Q dot ni macam mana dapat? So Q dot tu apa? So boleh tengok dekat sini. So that is the heat transfer rate. Heat transfer rate. So macam mana dapat Q dot? Q bagi masa. Okay, 30 kilojoule bagi dengan 5 second. So you dapat per second 6 kilojoule. Okay, 6 kilojoule. So macam mana dapat Q kecil ni? Q kecil adalah per unit mass. Per unit mass. So 30 bagi dengan 2. So 30 bagi dengan unit of mass 2 kg. So you dapat 15 kilojoule per kg. So that is how you can convert. So these are the things that you can always use. Okay, dalam calculation pun selalunya akan keluar lah. Dia akan cakap per unit mass, ataupun kita juga boleh panggil as specific heat transfer. Kalau ada perkataan spesifik ataupun per unit mass, maksudnya you kena bagi dengan mass. Kalau dia cakap over time, so you kena tahu dia adalah Q dot. So Q dot ataupun kalau dia dalam soalan dia tulis Q dot, you kena tahu itu adalah per second ataupun per unit time lah, per minute ataupun per jam. So yang itu ada yang ada Q dot. Okay, since heat transfer is the energy in transition across the system boundary due to a temperature difference, there are three modes. Okay, three modes of heat transfer. Yang ini kita akan belajar balik dalam chapter paling last. Chapter paling last adalah chapter dia adalah heat transfer. Okay, kita akan belajar balik, tapi I bagi as a introduction lah. Okay, ada tiga mode heat transfer. Okay, first adalah conduction, convection and also radiation. So kalau you baca dekat sini dia a bit panjang lah, tapi I try to explain. Conduction maksudnya apa yang bersentuhan, physical, ada physical contact. If you have physical contact, so katakan macam charger ni. Okay, charger ni I sentuh, so ada physical contact, ataupun you letak dekat table, so yang ni dia dipanaskan, charger ni dipanaskan. So then heat transfer is transferred to the table using a conduction mode of heat transfer. Okay, that is conduction. Sebab itu dekat sini ditulis interaction between the particle, the interaction between two medium. Okay, macam ni charger I letak atas table, so ada dua medium. Okay, conduction. Convection, heat transfer because of the surrounding air. Okay, convection. Convection maksudnya macam udara dekat yang ni contoh yang paling klasik adalah kenapa you jemur kain dekat luar. Sebab the surrounding air, satu you dapat yang ni saya akan bagi tahu nantilah, radiation. Radiation adalah daripada matahari ataupun emission of electromagnetic wave. So dari matahari ada electromagnetic wave, dia sampai dekat bumi. So you dapat dari matahari, you dapat abal tu melalui radiasi. Radiasi adalah berkaitan dengan electromagnetic wave. So that is what we call as a radiation. So normally kita the source of radiation adalah sun. Okay, matahari. So dari matahari, walaupun matahari dia berapa juta ribu kilometer dari bumi, ratus ribu kilometer dari bumi, tapi we still can get because of electromagnetic wave. Okay, so that is radiation. And convection, kenapa kita jemur kain dekat luar? Sebab dekat luar kita boleh dapat radiation dari matahari. So you can get radiation from the sun as well as convection. Convection dia happen macam mana? Dekat luar. Convection. We have wind. So we have wind. So dari tempat yang panas, wind akan blow. Then at the same time, dia kain you jemur keluar, dia dapat radiation, dia jadi kering. Dia akan jadi lagi cepat waktu ada udara yang panas yang tiup. Okay, especially when the windy day. Okay, sebab itu selalunya you akan jemur waktu pagi dalam pukul 10 ataupun pukul 11, baru matahari akan naik. So radiation akan maksimum, and as well as udara pun akan banyak. Okay, so conduction, dia punya keyword adalah physical contact. Okay, convection adalah pergerakan udara ataupun any fluid lah yang lagi panas, and the fluid is heated up and move away as a source of heat. Then after some time, dia akan jadikan udara dalam bilik ni panas. Okay, so that's one concept lah. Radiation I dah bagi tahu tadi. Okay, convection dalam bilik macam mana? Okay, so let's say macam aircon. Okay, aircon ada dekat sana, and you have dia akan create flow, air flow. So air flow, after some time udara dalam ni is cool down because of heat transfer by convection. Sebab ada air flow. Okay, so convection ni dia berkaitan dengan air flow. Okay, air flow. Okay, so ada soalan. I think another 5 minutes. Okay, energy transfer by work saya akan ajar, I think ada dalam 14 more slide. Saya akan ajar on Friday morning. Okay, so any question? Okay, so kalau tak ada, saya finish up the assignment, the attendance. Kamal Faris ada. Muhammad Aika, Firdaus Muhammad Farid, Firdaus Muhammad Farid, Muhammad Firdaus Romi, Ilham Amir, Khairul Azhar, Wafi Hakim, ada? Tak ada. Nur Fakira, Pritika, tak ada. Sharmila, Syahid Azimi, Sufian Davis, Syarul Anwar ada. Tilagan, Unku Arman Shah. Okay, boleh off.